The topic that we start today to discussing is factorization. It's the name of this, factorization. And factorization is extremely important. Without factorization, you don't understand anything after this lecture. And in college algebra, in advanced mathematics, we are doing factorization anytime, every day. So what is the idea for the factorization? Well, factorization is the opposite operation or opposite procedure of the multiplication. So you are super familiar when you have 5 times 3 is 15. Then this direction is multiplication. But in opposite direction is factorization. In the other word, I give you the result 15 and you break it down. Break it down using a prime number. Okay, I want to refresh your memory now about prime number. It's 3 and 5. So this is the factorization process. Break it down. And this is super important. Sorry, I didn't mean to send. Sorry, I didn't mean. What do you say? Okay, 5 and 3. This is factorization. Suppose. I to say now. Yeah. No. The answer is no. Okay, why no? Okay, because I want to explain something. Look, for example, you using to break it down prime number. Prime numbers. And what is the definition of the prime number? Prime number is the number that you can divide by itself or by one only. The rest of the number that do not satisfy this condition is a composite number. Okay? The prime number, the classical prime number is 2, is 3, never 1. 1 is totally excluded outside the prime number. 1 is no prime. 1 is nothing. 1 is a weird guy. 2, 3, 5, 7, 11, 13, 17, 19, after 23, 29, It's infinity sequence. It's continuous forever. You don't need to remember everything, no? It's crazy. The most common is, we working basically to 29 or so, but weird. Seldom 29. You using to break it down the number, only prime number. And prime number, no 1. 1 is totally out the prime. 1 is nothing. 1 is a weird guy. Okay? So now, I suppose you know that. This is elementary arithmetic. Okay, this is another algebra that you don't took before. You suppose you took before, depending your background. Suppose 180. Do the prime factorization 180. Okay. So you divide by prime number. But I recommend to organize the work. You start for 2. And you divide by 2, divide by 2, divide by 2, divide by 2. When it's impossible to divide by 2, you divide by 3, divide by 3, by 3, by 3. When it's impossible by 3, by 5, using this sequence. What is the clue? Que give me information that this number is divisible by 2. Or any number that ending in 0 or even number is divisible by 2. It doesn't matter if it's too long. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2. Ending in even number, this number without calculator, I know that it's divisible by 2. Or 0. You divide by 2, you put in a calculator, of course, it's 90. It's a calculator. 90 divided by 2, of course, because ending in 0. It's 45. 45 is divisible by 2? No, because ending in 5. By 5 or by 3, no es la. Okay, remember, you can do in different order, and the order doesn't affect your final answer. 45 is obvious it's divisible by 5. but it's also divisible by 3. So I recommend following the sequence. Okay, look, what is the mnemonic device to remember see one number, two long number? 4, 5, 3, 7, 6 is divisible by 3. Okay, 45. You adding 4 plus 5. You adding 4 plus 5, 4 plus 5 plus 3 plus 6 plus 6. You adding the digit. And the answer is 9 in this case. And 9 belong to the 3 times table of the multiplication. Because I know that 9 is 3 times 3. Therefore, 45 is also divisible by 3. Okay, 15, no? And this is 3 and 5. Okay, another possibility. Suppose that one student say, no, I don't like that way. You divide by 2. You divide by 2 is correct. Divided by 5 now. Sorry, 45, no? 45. Divided by 5 now, no 3, because I don't remember very well 3. So 9 and 3, 3. 9, 3, 3. Actually, the factorization is 2, 2, 2, 3, and 1, 5. Stay alone. So the order in which you perform the factorization, it doesn't matter. The factorization is unique, only one. It's the most important theorem in the arithmetic part. Okay? Entonces, I suppose that you are familiar. Prime number, you remember, no? Yes or no? Factorization. Okay, Noela. Factorization, you remember this format in another country using another format, but this is the format we are using in our college. Okay? 3 format. It's called that. 3 format. So I want to take advantage. To explain 2 important things. I want to take advantage to explain greater common factor because we are using every day GCF. So the acronym is GCF. When I put in the board GCF, everyone understands it's greater common factor. So for example, let's try to find the greater common factor. The greater common factor. The greater common factor. And another important thing I need to discuss is the least common multiple. Okay, it's LCM. Okay, by the way, it's equivalent, synonymous, the same thing of denominator. So when it's denominator, it's called least common denominator, LCD. Find the LCD, What is the formula? What is the formula for finding greater common factor? And what is the idea behind greater common factor and least common multiple? Okay. I forgot in that part because I want to use it now to express it. How you express it, the factorization 180? Well, 180 is 2 times 2 times 3 times 3 times 5, no? So 2, 2, 2, 3, and 1, 5. And if you want, you put it compact way like that. 2 to the second power, because we have 2, 2, times 3 to the second power, because we have 2, 3, times 1, 5. To the 1 power, okay, 1, you know, it's invisible. Okay, this is the compact way to express, not necessarily repeat, because sometimes too long. It's not good. Okay, so let me try to bring one easy example and one complicated example to find greater common factor and least common multiple, is the same of the least common denominator. Suppose find the greater common factor in between the number 9 and 15. Okay, I have no idea. Well, this is easy. Sometimes we can use intuition, but not always intuition works very well. Now, I recommend perform the procedure I want to explain now. You take 9 and 15, both. And you break it down in prime factorization. 9 is 3, 3. And 15 is 3 and 5. And the common factor, the word common indicate repetition. Okay, the only guy gets repeated is 3. 3 is repeated. And you take the smaller amount because we have 2, 3 here. and 1, 3 here. You take the smaller amount of 3. Okay. Well, this is confusing. However, I can explain it another way. Suppose you express a 9 like no 3 times 3, no 3 squared. And 15 is 3 and 5. 3 and 5. 1 power, 1 power. In order to find the greater common factor, you take the repeated case 3. 5, no. 5 is completely out the game because it's no common. And you take the smaller exponent, que 1. Okay? You take the smaller exponent, que 1. This is the idea behind the greater common factor that we are using from now every day. What is the GCF? What is the GCF? What is the GCF? It's a frequently question. Okay. Let me complicate a little bit. One more complicated using a big number. And after I want to explain least common multiple. Well, no, let's explain least common multiple now, using the 9 and 15. So what is the least common multiple or denominator? It doesn't matter between 9 and 15. Okay. Let me try to understand the idea behind this. Multiple, this word multiple indicates multiplication. A multiplication is, I suppose, the answer here that you get is bigger than 9 and 15 because it's multiple. Multiple is when you multiply of 9 is 18 when you multiply by 2, 27 when you multiply by 3, 36 when you multiply. So what is the idea? I want to explain the idea and after the shortcut to find the LCM or LCD in 1 second, no? 9 and 15. This is multiplication by 1. Multiplication by 2 is 18. 30, no? Multiplication by 3 is 45, Noela. You are right. Okay, but let me explain my lecture, Noela. Entonces, 27 and 45. Multiplication by 4. So you multiplication by 2, by 3, by 4, by 5, I don't know. By 4 is 36. And by 4 is 60, no? 60. And multiplication by 5. And 9 times 5 is 45. 5 times 15 is 75, no? And we continue, bam. However, I can see in the middle of the process que 45 is a common guy. It's a least common. I suppose que you continue 6, 7, 8. We have another common, but the least common is 45. The least common is 45. Do you understand this idea? Yes or no? But this method illustrates very well the concept. Pero it's not clear. It's too long. Stupid guy. Okay, no. I don't like that. So now I copy 9. Look, I copy this idea again. But I analyze a different idea. 9 is 3 squared. And 15 is 3 and 5. How you get the least common? Okay, the rule is, okay, we have no 5 here. So 9 is equal to 3 to the second power. And 5 no. 5 to the 0 power. You know, okay, so the 0 power always is 1. So you want to complete, no, the factor. Oh, no, not necessarily this. Entonces, in order to find the least common multiple, you take every factor. No like a GCF. In this GCF, you take the repeated, the common. No, in this case, you take 3 and 5, both. But how many 3 and how many 5? You take the higher exponent. So we have a 9, 2, 3. Look at that. You take both. And you ignore this 3. So the smaller exponent you ignore. You take, bring down 3 squared. And the 5, you have 5 here to the 1 power, no? 1, 5. And here we have no 5, it's equivalent to say que it's to the 0 power. So you don't like this, you erase. It's not important. Now you take every factor, 3 and 5, but you take for LCM the greater exponent. It's 3. When they're repeated, you select the higher exponent and you delete, ignore the smallest point, and take 5. And 3 to the second power is 9, and 9 times 5 is 45. And we get exactly the same answer. Good or not good? Okay, let me see if you understand or no this concept, que is important to me so far.
Professor,
Okay, go ahead.
I have a question, Professor.
Go ahead.
Yes, Professor. Instead of, in another way to do that, we can like divide like 45 like by the primary numbers and get the result.
Yeah, absolutely.
Thank you.
Let's do it now. I want to see you understand. We are doing by the traditional way. So find the GCF of this number 180 that we did before, 525. So using the intuition is crazy. Nobody can do that. And it's common multiple of the same number, no? 180 and 525. When the number is small, we can use intuition. So you understand very well the concept. But when the number is big, no. It's impossible. Nobody can. Okay, so now you take 180, which I did before, and break it down in primary factorization. And 525, and break it down in primary factorization. When I did that, I don't want to what's the time. It's 90 divided by 245. 45 divided by 3 is 15. And 50 is 3 and 5. Okay, if you want to write in compact way, 180 is 2 to the second power times 3 to the second power times 5. Everyone follow me so far, right?
Right.
525, of course, is not divisible by 2 because ending in 5. I know the rule que when the ending in even or 0 is divisible by 2, but no, si ending in 5 is divisible by 5. But just in case, let me check it by 3. You add in the digit 5 plus 2 plus 5. Oh, 5 plus 5 is 10 plus 2 is 12. Oh, and 12 belong to the 3 table because 12 is 3 times 4. That's possible divided by 3. So you divide it by 5, no problem. You get the same answer, but it's in another way, but it's okay. It's 175 when you put it in a calculator. And this is, let me see if it's divisible or not by 3. 1 plus 7 plus 5. 1 plus 7 is 8 plus 13. No. It's not divisible by 3. Hey, microphone, nice, noise. But it's divisible by 5. How do you know que it's divisible by 5? When the number ending in 5 or 0 is divisible by 5. Let me repeat the rule. One big number is divisible by 2 when the last digit is even or 0. One big number is divisible by 3 when you add in the digit and the number que is the result of the addition belong to the 3 multiplication table. So it's divisible by 3. And it's divisible by 5 when the last digit is 5 or 0. And there are another weird rule, divisible by 4, by 7. But no. That's not important. The most important is the rule of 2, the rule of 3, and the rule of 5. Okay, now, when you put in a calculator, 35. And 35, I break it down like a 5 and 7, right? Okay, so the factorization, 180. I copy again 2 square, 3 square, and 5 to the 1 power. And 525 is 3 one time. But not 0. So 2 to the 0 power gets missing. We have no 2. 3 one time. 5 two times. And 7 one time. Because we have 1. Okay, ready. To find the greatest common factor, the rule I memorize in my mind is you take the repeated factor, the factor gets repeated. Okay, the only guy gets repeated is 3. Yes or no? Look, common. 2 no. 5 yes. 5 yes. 5 is repeated. At least one time it's considered repeated.
That's 3, right?
3? No, 15.
No, 525 equals 3 times 3 times 5 times 7, correct?
525 is 3
equal
times 5 times 5 times 7, correct?
Okay, because it looks like a 2. Okay.
No. Because, okay,
It looks like a 2, Professor.
listen.
Gosh.
Because I consider one column for the 2, one column for the 3, one column for the 5, one column for the 7.
I see.
Entonces, okay, you see. Entonces, okay, but okay. Don't worry. I don't like this way. This is just academic way. Okay, maybe your way is more clear. 180 is 2 times 2 times 3 times 3 times 5. It's a 180. 525 is 3 times 5 times 5 times 7. Okay, now, no more delay. What is the greatest common factor? Repetition. 3 is repeated. But you take the smaller. O sea, you take, in 180, we have 2, 3. And 525, 1, 3. You take one, only one. And 5, you take one. Either one. This or this. Doesn't matter. And your multiplication, 3 times 5, 15. 15 is the greatest common factor. Okay? In conclusion, you analyze what factor is repeated. 3 and 5 is repeated, and you take the smaller exponent to find the greatest common factor. And least common multiple, no. You take every repeated and non-repeated. Okay? But when it's repeated, you take the bigger amount, the majority. Okay. 2 is not repeated. You take 2, 2. 3 is repeated. You take 3. You take 2, sorry. So you ignore the smaller. 5 you take. And 7 you take. Okay, the idea behind least common multiple is, I want to repeat again, gets confusing part. You take every factor, no omission. The factor involved in my problem is 2, 3, 5, yes, 7. Okay? And you take, but not to 2. I make a mistake here. Only 1, 2.
Yes, because it's on both sides, right, Professor?
1, 2, 2, 3. Majority, repetition, majority, no 3, 3. This is a typical mistake too. So, no, Professor, I take 3, 3. No. It's repeated. 180 have 2, 525 have 1. You take majority and omit. Because remember, we are finding a big number, but it's the least common, smaller. It's the smaller of the higher. Entonces, 1, 5 and 1, 7. Don't forget everything. That basically, you put in a calculator. In the calculator, you put 2 times 3 times 3 is 9, times 5 times 7 is 35. Oh, the answer is 630. This is the least common multiple or the least common denominator you need when you apply fractions. Okay? And the same idea happen when you have variable algebra. Let me try to explain. Suppose that we have that expression. Find the greatest common factor and the least common multiple of this expression. Just variable now. Suppose x to the second power, y.
Professor, before we go to this part, I want to understand the part that you explained.
What part?
Yes, the least common multiple.
That part.
Yes, Professor. Why you repeated like 3 2 times and you just repeated 2 in one time? Because when we did like the division, we have 1 3 for the 525.
Okay, the rule is clear. Look, you must take every factor, no omission. The factor involved in my problem is 2, 3, 5, and 7. You take. So in my LCM should be appear this guy. Pero how many? How many? Bueno, how many? Es obvio que 3, we have 2 here and 1 here. And you take always the majority. O sea, okay. Entonces, now, wait. Let me finish the idea. The idea is, when, only when one factor is repeated, you have to take the majority of them. Okay, otherwise no. Otherwise you copy exactly one time. Because the only guy no. We have 2 guys gets repeated. 3 is repeated because it appears 3 in both numbers. So you take 2, 3. There's a reason I take 2. 5 is also repeated. 5 is repeated. But in this case, no majority because we have 1 5 and 180 and 1 5 525. You take only 1 5. And the rest is non-repeated, you take 1 time. End the story. Clear or confusing?
It is clear.
Isn't the 2 repeated?
Say again? 2
Isn't the 2 repeated?
No, because 2 belong only to 180, not to the 525. When you say repeated, means que es en both numbers or in 3 numbers. Because the problem is possible solving not only in 2 numbers, 2 numbers, 3 numbers, 4 numbers, find the least common multiple in this number. Okay, it's not repeated because repeated means, que living in both numbers. Okay?
Yeah, there's no 2 on 525.
Exactly. Okay, so let's focus. You understand a little bit. I suppose in the practice, we reinforce the idea. Suppose que you find the least common denominator, but I want to use a variable. I'm using x, y, z, Entonces, now one expression is x squared y, another expression is x, y squared z. Okay, 2, not 3. Exactly the same here. Okay. And I apply the same rule. The great common factor is the common. The common in between this expression and this expression, I can see using my eyes, que es x and y, correct? C is not repeated. And for the greater common factor, you take the smaller exponent, que es x and y. End the story. You take this, and you take this. For the greater common factor. I ignore y to the second power and x to the second power. And of course, I ignore c because c is not common. Do you understand this or no? Yes or no? Yes or no? It's the same thing of the numerical, but using variable, using letter. Huh? Guy, answer me. You understand or no? Hey, what's going on?
Everybody's afraid to answer, Professor, but one thing. Isn't x 1? X to the power of 2.
Sí. Power. X to the second power, y, and x to the 1 power, y squared, c to the 1 power. Okay, the shortcut to do super fast. You take the common is when it's repeated, and you take the smaller exponent for the GCF. What is the smaller exponent? When x is repeated, because living in both expressions, I taking the smaller exponent, que es 1. Like y is repeated, I take 1 to the 1 power. However, the LCM is different because the idea is you take, when it's repeated, you take the greater exponent, the bigger exponent, and you take also the repetition. because you need to include everything. Entonces es x squared, y squared, and z. Okay? X is repeated, you take the bigger exponent, que es 2, you ignore this guy. Y is repeated, you take the bigger exponent, you ignore this guy. And C is not repeated, but I need to take for the least common. Remember the idea, the rule is you must take every factor. Numerical factor or algebra variable factors. Confusing?
Yes.
I know. Very, very, very. That's the reason that the student frequently don't understand very well the factorization, but I suppose that we are doing our best to understand in this course, no? Okay, look, but this is just the beginning. Don't frustrate for this. Hello. Okay, suppose now combination, number and variable. Suppose we have two algebraic expressions. Suppose 48 x to the second power, y to the cubic power, and why not z minus 2 squared. Okay, this is my first. My second is 24 x y 4 and c minus 2 to the 1 power. Okay, you know, when it's 1, it's invisible. You don't need to write. Find the greatest common factor and find the least common multiple. Okay, let me start for the greatest common factor. So for the numerical part, I like so much doing it that way. 48 and 24. Oh, it's an even number. 24, 12, 6, 2, and 3. This is the factorization 48. 24, 24, I did that. Okay. So what is the common factor? Okay, share both numbers. IC2, 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 IC3. Actually, this is a common, okay, share both numbers, right? Therefore, it's 2 times 2 times 2 times 3 is 24. It's obvious, no? It's obvious that the greatest common factor is 24. Yes or no?
Yes.
Yes, absolutely. Now let's move on to the variable part. X is common. I take smaller exponent. No 2, only 1. Y is common, no? Oh, yes. You take the smallest exponent, get 3, no 4. And this is considered also like a factor, no? C minus 2 squared. It's the same, it's common, but you take only one time. End the story. Gcf. Lcm. This is complicated guy. And the numerical part, this is obvious that we have 1, 2, 3, 4. This is 2 to the 4 power times 3 to the 1. And 24 is 2 to the 3rd power times 3. So the numerical part, the least common multiple, remember you take when it's repeated, 2 is repeated, but you take the bigger exponent. Okay, it's 4. And you ignore this. And 3 is only 1, 3. So actually, 2 to the 4 times 3 is 48. Okay, the least common multiple is 48. Makes sense, right? Because 48 times 1 is 48, and 24 times 2 is 48. This is, it's excellent. This was easy. This is some particular example that's easy to see, not necessarily analyze by factorization. No? We can use it in the common sense. And the rest is x to the second, okay? You take the bigger exponent, y QE, and c minus 2 squared. It's a coincidence que least common is a coincident with the first expression. Not always happen, of course. This is a particular example. Okay, so this is a short introduction to the factorization, prime number, GCF, and least common multiple. I promise that we are practicing from now every day this concept. And little by little, you understand. Okay? So I recommend. Let me see. Let's go directly to our package. Question one. Question one of our package is division. Okay, question one. Question one is, you have a trinomial. Do you understand what is the reason it's trinomial, right? Trinomial is because it's the algebraic expression that contains three terms. 1, 2, 3, trinomial. This is the name of it. Si es two terms, it's binomial. Binomial is two terms. More than 3 is called a polynomial. Polynomial is greater than 3. So 4 term, 5 term is poly. But okay, don't worry for the name. The name is not important. You divide trinomial divided by binomial. Divided by binomial gives x plus 9. Okay, let's do a division. Division to polynomial. Or polynomial, trinomial divided by binomial in this case. But in general, this method that I want to explain now is valid for any polynomial. And we use a long division. Long division, exactly the same we are doing in numerical. Long division, you organize inside the box the numerator, the top part, x squared plus 3x minus 54. And outside the box, you put the divisor. So the name of this guy is dividend. The name of this guy is divisor. Okay. And the divisor you put outside the box. And you start. Division. I try to find one expression here can multiply by the first guy. Give me exactly this. Es obvio que the expression that we are looking for is x. Because x times x squared. Okay, I did this multiplication. Now x times 9 is 9x. I put it here. It's important to keep the organization. One column for the x squared, another column for the x to the 1 power, is the 1 power, and another column to the x to the 0 power. No? Okay, 0 power is 1, it's invisible. Any number or quantity raised to the 0 power is 1. Okay, I did this multiplication. Now, to subtracting, you change the sign. Ooh, professor, why? Look, exactly the same we are doing in elementary school. Suppose you divide 5 divided by 2 by hand, no calculate. You put 2 here. 2 times 2 is 4. Subtracting, remainder 1. Remainder, quotient, dividend, divisor. Exactly the same we are doing in algebra. Long division. Okay, now subtraction. Subtraction is obvious. Okay, this is cancelled out, 0. And this is negative 6. And bring down negative 54. And you stop the division when the remainder, que es this guy, remainder is a polynomial of the degree less than the degree of the divisor. So the degree of the divisor is 1 because the big exponent is 1. The degree of the dividend, degree, is 2 because it's the higher exponent. Look. And you stop the division when you get degree 0 because the degree of the divisor is 1. Entonces in this moment you stop. No. Why no? Because the degree of this binomial is 1. It's the exponent 1. Look here. So you continue. Okay. So you put negative 6. Negative 6 because negative 6 times x and negative 6x. Okay, organization important, the column of the x. And negative 6 times positive 9 and negative 54. And by subtracting one more time, I change the sign. And the answer is 0. Okay, professor, but what is the final answer? Well, the final answer is, okay, the final answer of x squared plus 3x, que was the initial problem, no? Divided by x plus 9 is equal x minus 6. The answer is this, que es the quotient. Because we have no remainder. Remainder is equal to 0. When you have remainder, let's see what happened. Another different thing happened. But in this case, we have no remainder, so the answer is directly, you take the quotient, copy, and paste. Okay, I want to verification, quickly. The thing we're doing, let's do it backward, completely backward. Look at that. I apply gross multiplication. I consider that this is a proportion, this is another proportion, you apply gross multiplication. It's a remainder is equal less over. Remainder is the last answer. Look in the elementary division, the remainder in this case 1, no? When you finish the division. Let's check in just in case. I consider that this is a proportion. I apply why no cross multiplication. You multiply this trinomial multiplication by 1 is exactly the same. And x plus 9 times x minus 6, you multiply divisor times the quotient, and surprise, you apply FOIL. I suppose you remember very well FOIL. FOIL is the mnemonic device to remember very well the multiplication to binomial. Entonces, x squared, FOIL first, is say, this F is first. Acronic. This is outer. Outer is this guy. Minus 6x. X times minus, this is 6. This is inner. And this is last. So basically, when you multiply two binomial, we have 4 combination, no? And the 4 combination is first, outer, inner, and last. The order is not important. But why memorize something in order to organize my brain, no? Entonces 9 times x is 9x positive, of course. And last is positive 9 and negative 6 is minus 54. And finally, we combine like term x squared plus 3x minus 54. We get this statement is completely true. This is not mandatory to do that. It's only for checking that our division was correct in the story. Okay?
Can you please zoom out?
Zoom out. Okay.
Professor, can you explain again, like not the verification?
No. This was curiosity. See,
yes.
we are doing.
Professor.
Okay, it's similar. Oliveira, look, it's similar to, for example, I want to check this. Well, okay, you multiply 2 times 2 plus 1. Okay, the remainder in this case. 2 times 2 is 4 plus 1 is 5. And you get exactly the same dividend. In this example, the remainder was 0. Suppose that you divide 4 divided by 2. 2 times 2 is 4, subtracting 0. Now you want to check it, you are doing the opposite operation, get the multiplication. 2 times 2 should be 4. Get the dividend. Okay, super good.
Not, Professor, because I want to understand like the division of the exercise. For example, you did like at the first part, Professor, part of the exercise. I want to know if you multiply like the x with another x to have like to do the division or not.
Okay, somebody asked me a different question to say I need to focus on one question. Noela, your question is, I understand something. The thing is, you multiply x times x.
Okay.
The answer is x squared. Try to find the blue color. They put here x squared. You multiply 6 times, sorry, carajo. You multiply x times 9. You multiply the first. 6 is no in this moment. And this is 9. 9x. I copy here, 9x. Now you copy with the corresponding sign. Now you know that you need to subtraction. So you change the sign. That part disappear, and that part give me 6. Wow. Student send me this. Another class. Okay. Do you understand this or no?
Yes, Professor.
Okay, okay. So I combine -9 and +3 and -6. Okay, so far we are doing that part. And negative. Okay, now let me change the goal to explain. The next process is multiplication 6. 6 times x is 6x. And 6 times 9 is 54. By subtracting change the sign, sorry. No, this 54. This 54 is coming when I bring down this 54. In this case, it's a coincidence. And the remainder is 0. 0 remains. And the remainder is 0. This is the process. Okay. Noela, we have 2 more examples. And maybe you see clear now, okay?
Okay, thank you.
Okay. Another question, Ingrid say something?
No.
No, okay.
It's just that when you wrote foil, it's a math term, and that's the meaning. It's whatever is on text.
Okay, it's acronym first, outer,
Inner and last.
Exactly. This is a mnemonic device. No? You remember when you multiplication A plus B times C plus D, you multiply first AC, outer AD, inner BC plus BD. End the story. Clear? You can do it another way. Of course you can. Yeah. What means yep? Is yep or yes? Because you are picky with the pronunciation. Okay. You are very, very picky with the pronunciation.
No, I am not, Professor.
Okay, no. It was a joke. Okay, let's do it number 2. Let's do it number 2 now. Number 2. Let's do it number 2. Number 2 is the also division, right? You divide x squared minus 12x plus 32 divided by x minus 4. Okay. But I don't do it in that way. No, never. I'm using the long division format. I copy the top part inside the box. I copy the bottom part outside the box. Dividend, divisor. Okay, so you help me. To start a problem, I need one expression or number, I don't know, can multiply, let me put it in one box. I need to find something, can multiply by this guy, give me x squared. What is the expression? X, very well. So I multiply mentally x times x squared. Yeah, I put it here in the same column of the x squared. Yeah, I multiply mentally x times -4 is -4. -4x. Correct? Everyone follow me so far? Now subtraction. Now subtraction. And subtraction, you change the sign. Minus plus. This is cancel. Always happy. And this is -8. And bring down 32. Noela, you follow me?
Yes, Professor.
So, and what is my second number or expression? I need to find when you multiply by this, give me negative 8. Negative 8x, sorry.
Don't we divide next by -4?
No. This is not the procedure. Okay, my question, try to follow me. What is the expression here? One box. Okay, multiply by x, give me negative 8x. I need to find A, B, AX.
No, Professor, it's AX. I just did by accident.
Okay, it's 8. It's 8 or it's negative 8?
It's 8.
-8.
Oh, it's negative 8. Because negative 8 times x is exactly the same as this, negative x. Yes or no? Do you see que es negative 8? Negative 8 times x?
Yep.
And negative 8 times negative 4 is positive 32. But by subtracting, I change the sign. Positive, negative. Again happen, que es 0. Everything is cancelled, remain the 0. And this is my final answer. My final answer is just x minus 8. So the answer of that question is x minus 8. If you want to verification, you apply cross multiplication and FOIL. Pero no. Okay, so the answer, I don't remember. The answer for the question number 1 was C or was D? I don't remember. Bueno, okay, forget about. The answer for number 2 is obvious que es B, right? Que es x minus 8, correct? Correct or incorrect?
Professor, sorry, are we following the package here?
You have the packet or no?
Yes, I have, but we are following that because I thought the Excel.
I don't hear your voice very well. I see up.
Sorry,
no,
Professor.
Try to speak slowly.
Okay. Yes, Professor. The thing that makes me confused is why we divide by like -8, and when we put like when we are doing the division, we put +8. That is my question. I don't understand.
Well, the reason I suppose is because you need to get exactly the same sign. It's -8. Okay. Let me come back. Come back. Okay, in this important moment, I see, wait, what is the expression? What is the expression? I need to write here, explosive mind, I have no idea. But I need to get exactly the same of this. Multiply, what is the thing? Okay, multiply by this, give me exactly the same. Twin brother, no family, no different signs. Twin, image, exactly the same. And -8, very well. That is the reason. You answer by yourself.
Yes, Professor, but when we put like there, it's positive. I don't understand why. Why is positive?
Because, Nuela, the division process is multiplication, subtraction. The division process, the procedure is multiplication. Remember, 5 divided by 2. 2 times 2 is 4, subtraction. O sea, you apply -8. I know que es negative because this number is negative. Entonces, -8x plus 32. Because negative times negative is positive. Now I need to subtracting because division is multiplication, subtraction, several times. And subtraction is change the sign of the binomial and subtraction. 0, 0. Good?
Yes,
I like your question. Super good. Okay, you don't remember the procedure of the division is multiplication, subtraction several times. And in algebra, to subtracting means that you change the sign of the polynomial or the binomial, either way. Good? Okay. Let's do one more. Let's do one more. Yeah, I suppose in the review package, we are doing more. Division. This is the question number 1 in the test number 3. Division to polynomial. Suppose number 3, y squared plus 10y plus 25 divided by something, divided by y plus 5, okay. Okay, you apply the format for the long division. Y plus 5 outside the box. Es obvio que the expression que we need here is y, no? Because y times y is y squared. And y times 5 is 5y. By subtracting, you change the sign. This guy cancels, all we having, and it's a 5y. Bring down 25. Just bring down. Now the next expression, I suppose que 5, positive 5, because 5 times y is 5y. And 5 times 5 is 25. By subtracting, change the sign, 0 again. The answer is y plus 5. End the story. More clear?
Yes, it is.
Excellent. Very well. Okay, I want to change now the flavor. I want to study another thing, que es factorization. Let's go directly, guys. Let me explain. This is long, and you have to use in your memory. There are different methods to do the factorization. The first one that we are studying is using Gcf. Remember, and this is the first method that you apply always. Find the Gcf. The majority of the students, no majority, but some students forgot this idea. Okay, the first thing you should do when you face one problem of the factorization is find the Gcf. You need to find the Gcf. And when you get in your hand the Gcf, you factor out. Okay? Let's do problem number 4. This is the first method. Okay, we study today. Suppose 40 x to the 7 power, y to the 8 power, plus 72, x to the 2nd power, y to the 6th power, plus 72 again, repetition, nice, I like, x to the 4th power, and y to the cubed power. Okay, I need to find the Gcf. Entonces, I recommend you analyze separately the numerical part, 40, 72, okay. See, we have another number here, we incorporate for the analysis. But in this case, we have 2, because 72 is repeated, okay? 40 is even, 220. You put in the calculator, guys. Okay? No, this is easy, but another number que is not easy, you put in the calculator. 210, 25. Done. This is the factorization of 40. This is 236, I guess so. Let me check it just in case in the calculator. You put 72 divided by 2. It's obvious, right? 72 divided by 2. There you go. 36 is also even, so we continue divided by 2. It's 18, no? And 18 is even, and 9. And 9 is 3 and 3. Okay, so what is the Gcf? At least the numerical part. Remember, the idea for the Gcf, I want to repeat again, is you take the common factor. Okay, the common factor that both numbers share is 2, no? Actually, but how many do share? 3, 2, no? 3, 2. Yes or no?
Yep.
Okay, the great common factor. In this case, you take exactly the same amount. It's 8. Where come from this 8? 2 times 2 times 2. This is the Gcf of the numerical part. All right, let me analyze the GCF of the variable part. X is common, yes or no? X is common, yes or no?
Yes.
How many X share this expression? How many?
X.
How many X? 2X, 3X, 4X, AX?
There are three.
3. Look, let me explain it. X to the 7. 2. You're right. It's 2.
There's a.
Okay, listen. X to the 7 is X times X times X times X times X times X times X. 7, no? 1, 2, 3, 4, 5, 6, 7. X to the second is X times X. Only 2. X to the 4, X times X times X times X. I can see que al 2 share is common. Entonces, what is shortcut? You need to do this stupid thing every day. No, you take the smaller exponent, end the story. For finding GCF, you take the smaller exponent. You see, it's repeated in every expression. Of course, common. But how many is common? 2. And what about Y? What about Y?
Y is 3.
Y is 3. That's it. Y is 3. This is my GCF. And this is my first step. Find the GCF. Find the GCF. Everyone follow me? You are totally lost? You are totally confusing? I get it. Okay, Noela. Okay. And the rest is okay? Let me erase this, because we don't need that. You factor out the GCF. Factor out. Yeah, I copy out. A x squared y cubed. It was our GCF. Open new parentheses. Okay, and we dedicate one by one. Number 1, number 2, and number 3 inside. What remain inside the parentheses? Well, the first guy is 40. F40. If you factor out 8, it's like these two, and these two get out and stay alive 5. Entonces 5. And make it sense, because 5 times 8 is 40. And you factor out, you break it down in your mind, you break it down 40 like A and 5. Why A? Because A is important, because A is the great common factor. And stay alive 1, 5. And X, how many X stay alive? Stay inside?
3.
No, 5. Because we have total, we have 7, and we factor out 2. Okay. Yeah, you know the X squared times X to the 5th power is X to the 7. See, these 2 was part of the GCF you put out, stay alive inside. This is out, inside 5. And what about Y? How many Y?
It's 5.
Exactly. Plus, I go to the second guy. 72. The factorization was this. This is the fantastic idea, because I like so much factorization. These two, and these 2 go out. Stay alive 2, 3, 3 and 9. Another way, guys, you divide 72 divided by 8. 72 mentally divided by 8 and 9. It's another way. How many X? In the second guy? Wait. It's 9, no? How many X?
2, Professor.
No, because we have 2, and you put out 2, because the GCF, and we have no X. Do you see or no?
Yes, Professor.
And what about Y? How many Y? Inside. Stay inside.
3, Professor.
3, very well. Plus 9 again, because it's the same number. How many X? Stay inside.
We don't need it. No, we have 2, Professor.
2. And Y? No Y. Because we have 3Y, and these 3Y go out. Look at that. And this is the final answer. after the factorization. This was our first example to illustrate the idea for the GCF, the power of the GCF for the factorization. Okay? So step 1, find the GCF. Step 2, factor out. And you put inside, you open new parentheses, and inside the new parenthesis, you put the remaining part. The part can stay after the factorization. Clear or confusing? One more example. You lie. Okay, good. You lie.
Can you please zoom out?
Yes, of course. Okay. She lie.
Yes, thank you.
Okay, let me erase the board. Okay, let's do a second example. Number 5 question is 6 x to the 12 minus 12 x to the 9 plus 18 x to the 6 minus 24 x to the third. Factorization using GCF. Number 1 step, find the GCF. Find the GCF. Let's analyze the numerical part. Numerical part is 6, 12. I don't care the sign. 18 and 24. Well, we have 4 numbers. Okay, this is doesn't matter. This is 2, 3. The factorization. This is 2, 6. 2, 3. You continue factorization. You continue break it down until you get prime number. So you break it down 2 and 6. You don't finish because 6 is composite number, no prime number. Now this is 2, 9, 3, 3. And this is 2, 12, 2, 6, 2, 3. Okay, so what is the GCF? What is the common factor que 4 numbers share? Bueno, 2 I saw que es common. Look at that. And 3, yeah, 3 is common. One more is common. No more, huh? Bueno, 2 is common in between this and this. Pero I have no more factor in 6. I finish. Okay?